All right, guys, today we're moving on to the last method we're going to be using for solving quadratic equations, and we've kind of saved the best for last. I'll go ahead and tell you. But the other methods that we have used can only be used in certain situations. For example, if a quadratic function or equation is factorable, then you could use factoring. We learned in our last session if it's not factorable, but yet we have a term of 1 that possibly we could use completing the square. Well, this particular method we're going to use today can work for any kind of quadratic that you are given. So let's go over real quick. Our standard form of a quadratic equation, again, is ax squared plus bx plus c equals 0, okay? And if we had lots of time today, which we don't because I'm trying to keep these videos short and sweet and to the point, I would actually go through a little proof and show you that the quadratic formula that we're going to look at today is actually derived from this particular standard form. But for the sake of time and again, just kind of getting through this as quick as possible and giving you opportunity to see some examples, I'm just going to give you the quadratic formula. And so here it is in all of its glory, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that looks crazy and daunting, but again, all of this information we're already going to have at our disposal. Notice that our letters that we're given here is a, okay, we're given b, and we're given c, all to plug into the formula. So literally, if you're a formula person, you're really going to like this because this is just kind of plug and play. And again, you're going to see real quickly how that it will work with quadratics that normally you cannot solve by any other method. So let's just throw out an example here. We'll call this number 1, and we've got 2x squared. Sorry, I've already made a mistake. It's okay. Minus 8x minus 17 equals 0. Okay, so you notice we have this standard form kind of already laid out here, but you also notice that I've got a 2 here that I cannot factor out, and so it's really not anything I can get rid of. And if we were to multiply 2 times 17, we're going to see that this is just not something that's going to come out that's factorable. And so literally what I want you to think about again here, you've got ax squared plus bx plus c equals 0. You've kind of got that same format. So all we're really going to do here is we're just going to plug in the values of a, b, and c into our quadratic formula. So here we go. We've got x equals negative, and here's what I want to tell you about this formula. Anytime you see a negative in formulas, I want you to understand, and I'm going to make that a different color just because it stands out. Anytime you see a negative in a formula, I want you to understand that that negative has to be there, okay? So we're just going to go ahead and do that right off the bat. I'm going to go ahead and put the negative, and then you notice my b term is actually a negative 8, okay? It's a negative 8. So I'm going to have negative 8 here, okay? Plus or minus the square root of b squared. Now remember, b is negative 8. So anytime I've got a negative that I'm squaring, I'm going to go ahead and put that in parentheses just so that my calculator does not mess up on me, because it's very easy for the calculator to make some mistakes here. Then I've got negative. Remember that negative is part of the formula. 4 times a, my a term actually is a 2, times my c term, okay, which is negative 17. So I want you to notice all we're doing is we're just plugging this into the formula. And this looks crazy right now. It looks like something that there's no way we'd be able to solve. But again, all we're doing is just using this formula and using our parts that we've already established from standard form of a quadratic, and we're just plugging it in. So the last thing that usually gets forgotten is down here at the bottom, you have 2 times a. And again, my a term is a 2. So now at this term, really all we've got is we've just got a lot of math that we've got to simplify and try to work out. But this is something that you can definitely do. So negative 8, that is going to turn to a positive 8. Again, we're going to keep our plus or minus square root negative 8 squared. So that's the same thing as negative 8 times negative 8, which is 64. And then again, here you could actually kind of plug all this into the calculator and get this calculation. But you've really got negative 4 times 2 times negative 17. So you've got a negative times a negative, which is going to be positive. We know that for sure. Then we've got 4 times 2 times 17. I'm going to go ahead and kind of do that math for you. Is 136, okay? All over 2 times 2, which is 4. So you can already see that this starts to clean up nicely, and we're going to get to a solution here actually pretty quickly. Okay, so the next thing we need to do is just kind of clean it up a little bit more. I've got 8 plus or minus. Notice here I've got 64 plus 136. So that is the square root of 200. And that's still all over 4. Now, right here at this point, you may say, well, I'm done. I'm finished. And that would be incorrect, right? Because, again, I've got to look at this square root of 200, and I got to see if there's any perfect squares that can be pulled out here. And this is why we spent so much time in simplifying radicals, is because, again, you're going to use this. This is something you're going to use not only in this class, but you're going to use it in college algebra as well. So let's think about the square root of 200 here. Let's think about perfect squares that will go into 200. And if you just think about this real quickly, you would probably very quickly realize that if I go all the way down here to 10 times 10, which is 100, 100 will definitely go into 200, okay? So let's go ahead and work out that piece kind of over here on the side, and then we'll plug it back into our answer, okay? So the square root of 200, if I look at that, I can rewrite it as 100 times 2. And again, the square root of 100 is 10. So this becomes 10 radical 2, okay? So that square root of 200 in its most simple form is 10 radical 2. So let's rewrite this answer that we're going with here. 8 plus or minus 10 radical 2 over 4. Now, here's what I want you to think about. I want you to think about greatest common factors. And think about, is there any number that will go into 8, that will also go into 4, that will also go into 10? Just think about that for just a second. What number will go into 8 and 4 and 10? And if there is a number that will go into all three of those numbers, then we could basically pull that out. Now, I'm not looking at this radical at all. That's just kind of got to stay where it is. There's nothing I can really do with that right now. But if you think about it, 2 will go into all of these numbers, okay? So there's one more simplification that we can do here that will really solidify this. So 8 divided by 2 equals 4. Plus or minus 10 divided by 2 would give me 5. Again, the square root of 2 just kind of stay the way it is. And then 4 divided by 2 would in fact be 2. Ladies and gentlemen, there is your answer, okay? So for problems like this that are unsolvable by using factoring or any other method, you can use the quadratic formula, which again is right up here. You can use the quadratic formula to help you solve any quadratic. Doesn't matter what it looks like, even the ones that are factorable, you could plug them into this quadratic formula and it would work. Now, there's another piece of this quadratic formula that I really want to talk about and spend the rest of our time on, because these problems, again, they're just algebraic. You just kind of work them out. But I want you to understand that there's something very special in the quadratic formula. So let's write that again. I'm going to write it down here. You've got negative b plus or minus, and again, this is x equals, so this helps you to find what the x values are. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, there's a very special part of this. I'm going to go ahead and highlight it now. This part that's underneath the radical sign. So this part underneath the radical sign, it actually has a very specific name. Okay, it is called the discriminant. The discriminant. And so, again, just looking at this discriminant actually can help you to come up with a lot of different methods, and actually will help you to understand how many solutions you have without actually working the problem out, okay? So let's just look at some examples. I think this will make more sense, and then we'll kind of establish the rules. So we'll call this number 2. So I have x squared plus x minus 42 equals 0. Okay, again, all I'm worried about with this particular part, and this is when they're asking you how many solutions is this quadratic going to have. Well, actually, all you have to work out is just this discriminant part, okay? So let's think about this, and we'll do this on the first one. We won't have to do it on the next ones because you're going to know what to do. So ax squared plus bx plus c equals 0 is our standard form, right? So now that means that this is a, this 1 in front of this. The b here means that there's also a 1 right there. and the C would be my negative 42. So I literally take those pieces of information and just do this discriminant piece on them. So let's work through this. We're going to have B squared. So that's just going to be 1 squared minus 4 times A, which is also a 1, times C, which is a negative 42. Okay, if we do this math here, I'm going to get 1 squared, which is just 1. Negative times the negative is going to be positive. And so I'm really multiplying 4 times 1 times 42. And 4 times 1 times 42 is going to give me 168. And so I'm going to end up with an answer of 169, okay? So if my discriminant here is greater than 0, I'm going to have 2 solutions, okay? And I'll tell you what, I'm going to go ahead and bring up Desmos really quick here. And let's see if we can't just prove that out to make sure that makes sense. I spelled Desmos wrong, but it's okay. Desmos graphing calculator. We'll go ahead and bring that up. And again, I'm going to do x squared plus x minus 42. And I want you to notice what happens here. Notice what happens. How many solutions do I have to this quadratic equation? Remember, my solutions are where it crosses the x-axis. And you'll notice here, I do have 2 solutions, okay? So anytime you're dealing with a quadratic and you're looking to just figure out how many answers is this thing going to have, you can just do the discriminant. And if the discriminant is greater than 0, then you have 2 solutions, okay? So let's look at another example here. We'll call this one number 3. So number 3, we have x squared equals 18x minus 81. Now here's the thing you really got to be careful about. You got to be careful as to whether you are in standard form or not. Because if you're not in standard form, then really you don't know what pieces are which. For example, where's A, where's B, and where's C? And are they the right signs? Well, right now they're not because they're set up like this, okay? So we need to get it to look like standard form, which is this up here. So that means I need to move my 18x across the equal sign. So it's going to be x squared minus 18x. And I need to move this 81 across the equal sign as well. So that's going to be positive 81. And that is going to be equal to 0. Okay. So again, I'm going to do the same thing again. I'm going to do the discriminant, which is just simply the part that's underneath the radical. So b squared minus 4ac. B squared minus 4ac. So I've got negative 18 squared, because this is my B term, minus 4 times A, which again is a positive 1, times C, which is a positive 81. Okay, and if we did all of this math here, if you can take every bit of this and put it into the calculator and just see what it gives you. And if you do that, you're going to get an answer of 0. So when we do the discriminant, it gives us an answer of 0. So think about what that really does to the quadratic formula. Here, if I have the square root of 0, that's just going to go away. And so even this plus or minus that's in front of this, all of this is going to go away, and it makes sense then what actually happens. Actually, when the discriminant equals 0, you only have one solution. Okay, so let's go over this again real quick. If your discriminant is greater than 0, you have 2 solutions. If your discriminant equals 0, you only have one solution. Real quick, I want to go back to Desmos again, and let's just look at this. Let's go ahead and put this particular equation in here. So again, I've got x squared minus 18x plus 81. It's what we had in standard form. And notice what happens here. Notice in my graph, I'm only touching the x-axis at one particular point. So that means there's only one solution, only one value for x that will make this statement true, that will make it equal 0. Notice I have 9, 0. So again, we're kind of seeing a pattern here that's happening with this discriminant. So let's do one more example, and you're going to see what's going to happen here. So on number 4, let's say that we have 2x squared minus 5x plus 7. And that's, again, equal to 0. And so, again, we're only focused on the discriminant. That's all we're worried about is this part right here. We're worried about the part that's underneath the radical sign. So I'm going to be looking for b squared minus 4ac. I'll just kind of write it over there so you can remember what we're doing. And so if we think about this, this would be negative 5 squared minus 4 times a, which is 2, times 7, which is our c term. And again, we've got a, b, and c right here. So let's take a look at what happens. Negative 5 squared is 25. Negative 4 times 2 is 8. And negative 8 times 7 is negative 56. So I actually end up with a final answer of negative 31. I wonder what kind of solutions that's going to give me, because think about this. Up here, greater than 0 was 2 solutions. Less than 0 or equal to 0 was 1 solution. Now I come up with something that is actually less than 0. I come up with a negative number, negative 31. I wonder what's going to happen with this particular graph and if we're going to have a solution. So let's go ahead and see. Let's go into Desmos one more time. And I'm going to go ahead and type in this new equation that we have. 2x squared minus 5x plus, I'm sorry, I put equals, plus 7. And look at what happened here. Is my graph crossing the x-axis at all? Here's the minimum point. But you notice even my minimum is not touching the x-axis at all. As a matter of fact, I don't have any points that are touching the x-axis. And so we know then that there are no solutions. There are no values of x that I could ever put into this equation that's going to make it cross the x-axis. And so you notice that anything that the discriminant is less than 0, I have no solutions, okay? So this is the part really that you're going to be doing, is it's going to give you a quadratic equation just like we had over here. You're going to take just the discriminant, just this part underneath the radical, and do that for that particular equation that you've been given. And if your answer, see, this would be your answer, like this one was 169. 169 is definitely greater than 0, so that says we're going to have 2 solutions. And so your answers are just going to be either whether you have 2 solutions, 1 solution, or no solution, depending on what that discriminant is. Okay? As always, make sure you contact me or Miss Wheeler if you need additional help, and we would be glad to help you. Guys, we only got one more section after this one, and then we're going to be ready to test on this subject that has seemed like it's taken forever. But again, this has been a really big chapter, and it's a really big part of our learning going forward, so it's really important that we do this. So again, if you need any help, make sure to reach out to us, and we'd be glad to help you. Thanks, guys.